Hi, welcome to the help session. We're going to be covering matrix algebra multiplication today in the next part of the matrix algebra operations series. So we're going to just jump right into it because I think this will be sort of long with the second part. The first part of this is scalar multiplication. So a scalar multiplication is multiplication of a single number like an integer multiplied by a matrix. So we're going to take a very easy example here. We're going to take 5 multiplied by the matrix of 0, 1, 4, 3. And so the way you do this is you just multiply each of the values within the matrix by the scalar. And so this is very simple. You're going to get 5 times 0, 0, 5 times 1, 5, 5 times 4 is 20, and 5 times 3 is 15. Right? Because all you have to do is multiply the scalar by each of the individual values within the matrix, and then place those products in the correct places of the new matrix, which will be of the same size. Okay, so that gets scalar multiplication out of the way. Again, very simple. The real part of this comes with matrix and matrix multiplication. So the rule here, which you can read on your own while you can pause the video and read this. I'm going to visually explain it. So matrix multiplication. Matrix multiplication is a little bit more involved than scalar multiplication. I'm going to write an example here. So example 1, it's going to be the matrix 1, negative 1, 2, negative, and then let's draw a matrix here. This will be 1, 2, and 3. Okay. So we have this matrix and this matrix. If you read here, it says we have the first matrix being m by r, and we have the second matrix being r by n. And this is just denoting the size of the matrix that we have. And so they're saying that it's defined when the two r's equal, and that the final matrix will be the size m times n. So let's take a look at this. We have the first matrix, which is m by r. Well, m is going to be the height of it, so it's going to be 1, and then by or times the width of it, which is going to be r. So there's 1, 2, 3 values, so the width of this matrix will be 3. And then we're going to look at this this second matrix, so it's going to be r by n. And so r is going to be the height, just like m was the height here, which is only 1. Well, the height here is 3, and the width here is 1. And so the width here being 1, we're going to check if these r values are equal based on this rule that we have up here, saying that if the r values are equal, as in this r value and this r value, if they're equal, then the product is defined. This means that if the r values are different, like they do not equal each other, then you're not able to complete it because it's going to be an undefined sum. That's actually what it's called, undefined sum. That will be the answer if you're ever asked that. However, since the r values are equal here, we can continue on. And from this, we know that the final matrix, which is what it's going to be equal to, is actually going to be of size m by n. So these two values here, since this corresponded to m by r, and this corresponded to r by n, then we know that the final matrix will be m by n, which will be 1 by 1. So it would actually just be a 1 by 1 matrix, which would just hold a single value. And so the way we evaluate this is we want to go from the first column and first row of the first matrix, and we want to start from the first column and first row of the second matrix, but we want to move across the first matrix while we move down in the second matrix at the same time. So when you move one value across in the first matrix, you want to move one value down in the second matrix. Okay, this will seem sort of easy for the first one, but in the second one it becomes a little bit more involved. So let's complete this. So we're going to have the product matrix, which will be 1 times 1. We're going to go. Let me get a different color. We're going to go 1 multiplied by 1, so which will be 1 multiplied by 1 plus negative 1 multiplied by 2, negative 1 multiplied by 2, plus 2 multiplied by 3, 2 multiplied by, let's not get ahead of myself, 2 multiplied by 3. And this is going to be equal to Well, 1 times 1 is 1, plus negative 1 times 2 is negative 2, so 1 plus negative 2 is negative 1, plus 6, so negative 1 plus 6 is 5. So 5 is going to be the only value in our 1 by 1 matrix. That's pretty simple, right? Well, let's scale it up a little bit. So we're going to try and remember that rule for now because it's actually going to be important right here. We're going to create a second example, and this example is going to use a 3 by 3 matrix and a 3 by 2 matrix. So the first matrix is going to be 3 by 3, like I just said. It's going to be 1, 0, negative 1, 2, 1, negative 1, 2, 0, 0. That's going to be a 3 by 3. And then we're going to multiply that by 1, negative 1, 2, 1, 3, and 2. That's going to be our second matrix. So now if we remember, we need this to be m by r, and this to be r by n. Well, let's check this. Well, the first value in this is always going to be the height, and the second value is always going to be the width. So m here will be the height, r here will be the height, r here will be the width, n here will be the width. It's just height by width. So let's check the height. We have 3 values, so the height is 3. We have 3 values horizontally, so the width is going to be 3. And then we're going to check here. The height is 3, so r is going to be assigned 3, and n is 2 because there's 2 values horizontally. And so we check these. They are equal, so we know this product will be a defined sum, or a defined product. And then we can tell what the m by n matrix is going to be. It's actually our final matrix, our final product matrix will be a 3 by 2 matrix. Okay, so here comes the fun part. This is going to take some practice to get accustomed to, because it is a little challenging the first time you do it. The way you multiply matrices is the same way we did up here, the same way we did in problem 1, but it's just a little bit more involved with a few more steps. You want to take the first value in column 1, row 1. Column 2, let me just name all the columns here really quick and the rows, just to make it very simple when I'm trying to identify things. Column 1, column 2, row 1, row 2, row 3. Okay, so we're going to have 6 values here because this is going to be a 3 by 2 matrix as defined by the m by r and r by n rule. We're going to multiply, let me get another color to differentiate. We're going to multiply across, so first value, first column, first row, first column, it'll be the first value, except like I said before, when you move to the right in the first column, which is this, or the first matrix, you need to move downwards in the second matrix. So when we move to negative 1 in the first matrix, we need to move to 2 in the second matrix. So this is going to be 1 times 1, which is 1, plus negative 1 times 2, which is plus a negative 2, and then it'll be 2 times 3. So let me draw that out. Hopefully that's a simple enough concept. It shouldn't be too confusing when we move on to the second row. When we move on to the second row in the column, in the first matrix, you have to stay in the first column of the second. The only time you shift columns in the second is when you get to the last row and you complete the last row in the first column. I'll show you what I mean. So for this next spot, we're going to have 0 times 1, which is 0, plus 1 times 2, which is 2, plus 0 times 3, 0. Next one, negative 1 multiplied by 1, negative 1. 2 multiplied by 2, 4, plus 4. 0 multiplied by 3, plus 0. Okay, now this is when you move over to the second column. Once you finish all the rows here, that's when you move over to the second column and you redo the process. So now it's going to be 1 multiplied by negative 1. So 1 multiplied by negative 1, 1, negative 1. Negative 1 multiplied by 1, because we're still moving down when we move to the right, remember. Negative 1 multiplied by 1 is also going to be negative 1. And then 2 multiplied by 2 is going to be plus 4. And now we're going to move over, or we're going to move down one column in the first matrix, and we're going to move to the or we're going to stay in the second column now, because that's the only time we shift when we get to the bottom of here. So 0 multiplied by -1 is 0. 1 multiplied by 1 is +1, and 0 multiplied by anything is 0. Now we're going to move to the third row, which is -1 times -1, which is 1. 2 times 1, which is +2. And then 0 and 2, anything multiplied by 0 is 0. All right, cool. Now let's evaluate this. So all you have to do is collect these together, evaluate them as a whole, and you'll have your final matrix. So take this value. This will be 1 plus -2, which is -1, plus 6, which is 5. And then we're going to have 0 plus 2 plus 0, which is 2. -1 plus 3, plus 4 is 3. And then we're going to have the second column, -1, -1, so that'd be -2 plus 4 is 2. And then we're going to have 0 plus 1, which is 1. And then we're going to have 1 plus 2, which is 3. And there you have it. That is your final matrix after matrix multiplication. If you have any questions about this, make sure to leave a comment section below. I think I was able to explain this fairly well and use the rule intuitively enough to explain these two problems. It's a fairly simple operation, but to make sure you have this down, you really need to just practice, just to make sure that it's obvious that when you move over to the right, you need to also move down in the second matrix. So when you move from the first value in the first values in each, and you move to the second values in each, you move to the right in the first and down in the second. Okay, so if you have any questions, either rewatch the video or leave a comment. And yeah, thank you for watching. See you later.